Hi everybody. Next few days we'll be working with rational expressions, and rational means ratio. Ratio kind of goes with fractions, so it's like a polynomial over a polynomial, or some expression or some function over another function, but we are simplifying rational expressions today. We'll be adding and subtracting, we'll be multiplying and dividing in the next few days. One of the things we want to discuss today is what is the domain of a rational expression. And the domain is the set of real numbers for which the rational expression is defined. What numbers can you put in the rational expression and you can generate an answer? So the first thing I'm going to do is just deal with problems like from page 48. On page 48, I'm looking at numbers 5 through 16. And if you have, first of all, like number 6, that's just a straight out polynomial. And we're just working on domain there. And usually polynomials, all real numbers. You can stick all real numbers. Now on number 6, you got 6x squared minus 9. But then you have the x is greater than 0. So if this weren't here, I would say all real numbers. You can put any real number in for x and figure out what 6x squared minus 9 is. But here it says we want to keep x greater than 0. So when I go for the domain of this, I would just say all real numbers, well, all greater than 0, so all positive real numbers. That's what I would call the domain on number 6. So for a polynomial, usually it's all real numbers unless they tell you differently, and that's what they did on number 6 here. Now, if I get ratios like number 8, and that's kind of a rational function, like 1 over x plus 5. What I do is look for, you can't have, when you have a ratio like this, the denominator cannot equal 0. Well, what's going to do that? If x plus 5 is 0, that's our denominator. X plus 5 can't be 0, so x cannot be negative 5. So if I'm going to give the domain, it's going to be all real numbers. So it's easier to talk about what it can't be here because it's just one number it can't be. It can be all real numbers except negative 5. Now, I think we'll do this. Let's just get in the habit of also doing interval notation here. So I need x greater than 0. So if I put 0 here and go to infinity, I'm describing it in interval notation. Here's in words. In interval notation, I can go from negative infinity to negative 5, but I can't have negative 5. And that'll take care of this side of negative 5. Then you put this u here. It's for union, or it's for or. And then negative 5, notice the curved bracket on it, to infinity, this would be the interval notation for all real numbers except negative 5. So negative infinity all the way up to negative 5, but not including negative 5. Start with negative 5, jump over it kind of on the other side, and negative 5 to positive infinity. Notice the curved bracket on negative 5 on this side as well. And if I were doing a problem like number 10, where I have x minus 4 over 1 minus 2x, well, the first thing I'm going to tell you is I'm not real worried about the numerator being 0, but I am about the denominator. 1 minus 2x cannot be 0. You cannot divide by 0, so that's just an undefined function, so that's going to affect our domain. So I've got negative 2x is going to not equal negative 1. Then when I divide by negative 2, x is not going to be 1/2. So when I talk about the domain on number 10, I'm talking about all real numbers except 1/2. And I'll do the same thing I did here. So from negative infinity, still all the way to the left until I get to 1/2, not including, and then not including 1/2 again on this side, to positive infinity. Basically the number line, if I were to put it on a number line, if 1/2 is here, I got an open circle here, I got a heavy arrow here, and I got a heavy arrow here. I could have done that on number 8 as well. But just an open circle on 1/2, that's the only thing that leaves that out on the number line. All right. I do want to do, let's say, I want to do number 14, because that is a square root function. Square root of 2x minus 5. Now, you've got to make sure that what is under the radical is not negative. It can be 0. 0 is okay under radical. Square root of 0 is 0. That's an answer. But square root of a negative is not real. It's not a real number. So I got the square root of 2x minus 5. That means 2x minus 5 can't be negative. Well, to not be negative means that it's going to be greater than or equal to 0. If it's 0, it's not negative. It's greater than or equal to 0. So if I add 5 to both sides, I got 2x is greater than or equal to 5. So now I'm kind of, when I do this one, rather than thinking about what it can't be, I'm thinking about what it can be underneath the radical. And 2x minus 5 is the expression under the radical. So when I divide by 2, I've got x is greater than or equal to 2.5. Well, let's see. And I could write out all real numbers greater than or equal to 2.5. But actually, I'm not going to do the number line. I started it, but I changed my mind. When I give the domain, I'm including 2.5 in the domain. 2.5 makes this 0, and we can find the square root of 0, which is 0 once again. Okay? I'm going to list 2.5 to infinity as the domain on 14. On number 16. Now 16 is kind of a different kind of problem here. Okay, it's got a square root, but the square root is in the denominator. So this time, the denominator can't be 0. It's okay to be 0 up here. This is not in the denominator. It's just, we can take square root of 0. We can take square root of 0 here, but when we take 1 divided by 0, then it's undefined because of the fraction. It can't be negative, can't be 0. So I'm going to say x plus 2, rather than just greater than or equal to, I'm just saying greater than 0, because I don't want 0 this time. So I'm going to subtract 2, and I've got x is greater than negative 2. That's my domain. Put that there. My domain for this one, I'm going to put a curved bracket around negative 2 and go to infinity for that one. Okay. I'm going to have you guys, part of what you'll do is I want you to do 5 through 15, the odds. And on a block, I'll have this video on one block in PowerSchool, and on another block I'll have you place where you can submit all this. Now, I do want to go to simplifying, which was kind of the topic. I just want to do a couple of the simplifying problems. And I may go down to a problem like number 22. Okay, before I do that though, when you simplify, rational expressions, I want you to, first of all, factor, if that's a thing. Second, I want you to determine the domain. And third, I want you, after you have factored it, determine the domain, I want you to simplify. I want you to cross out any common factors that match up in the numerator and denominator. So what do I mean by that? Let's look at number 22. X squared minus 25 over 5 minus x. Now I'm going to factor it, and that's a difference of squares. I got x plus 5 times x minus 5. I'm going to do something here. I'm going to take negative 1, and if I do that, then I go x minus 5, and negative 1 times x is the negative x. Negative 1 times negative 5 is the positive 5. That gets those to match up. Now I'm going to cross those off, but I do want to think about the domain while it's still factored. Notice that 5 minus x can't be 0. So if I subtract 5, negative x can't be negative 5, so x cannot be 5. All right, let's keep that aside for our final answer. Just keep that in mind. So we've talked about the domain here a little bit. I'm going to cross out the x minus 5s, and then I have this is equaling x plus 5 over negative 1. I'm going to rewrite this. If I divide, that's negative x plus 5, which is equal to negative x over 1. Negative x plus negative 5. So that's negative x minus 5. But then let's put in the fact, part of the domain, that x cannot equal 5. Okay, we can put 5 in easy enough here, but in the original we can't. It would be undefined in the original. So that's why we have to look at the domain before we do all the canceling out. All right, that's 22. let me have you look at oh heck, let's go ahead and do 30. This video is getting kind of long, I know. This will be our last example. On number 30, I've got x squared minus 1 over x cubed plus x squared plus 9x plus 9. So we have to go in some of our old factoring problems. I'm going to factor x squared. Well, I know what x squared minus 1 is. I know that that's going to be x plus 1 times x minus 1. That's a difference of squares. On x cubed plus x squared, I'm going to factor out an x. So I'm going to x squared actually, and I'll have x plus 1, and then I'll factor out a 9, and I'll have x plus 1. So I'm using grouping right now, and when I write my answer, my common is x plus 1. That is actually x squared plus 1. Ow. No, I was right the first time. It's x plus 1, and then here's x squared plus 9. Okay. Now, domain-wise, so I factored it. Now I'm going to get the domain, and sum of squares, that doesn't have a factoring pattern to it. X can't be negative 1. Now here's something that's interesting. X squared plus 9 cannot equal 0. I don't think that's going to be a problem. X squared cannot equal negative 9. Well, if I square something, if it's positive, it's going to be positive. If it's negative, it's going to be negative. So this is kind of a moot point here. So my domain is, this will always be something bigger than 9. 9 or bigger, I guess. So as long as x is not negative 1, our denominator is not going to be 0. All right, well now it's time to do the cancel step here. And we have the common factors of x plus 1. So my final answer, I'm going to write x minus 1 over x squared plus 9. And x cannot equal negative 1. All right. Now, for this part, I would like for you to do, let's have you do numbers 19 through 29, but only the odds. All right, so I gave you 5 through 15 odds, and now I'm giving you 19 through 29 odds. Okay, so I will have you post this, the notes, and the bookwork that were given here, and you'll see it on PowerSchool. I'll have you post that for your homework, well, for your classwork today and your homework. All right, guys, you take care now.